All right, hey everyone. I apologize for my absence today. So in lieu of that, to help you prepare for being able to do the content we were going to learn today and to create a handout that'll be due on Wednesday, I'm making this video for you. And so today we're going to be talking about what are called rational exponents. So these are exponents that can be written as rational numbers, which rational numbers, that word rational has the word ratio in it. So these are exponents that can be written as ratios, or ratios are another word for fractions. Okay, so let me show you how this works. And this is going to relate back to what we were doing last week about roots. Okay, so let's say we have something like this, where we're taking a root, and I'll use the nth root, okay, of something raised to a power. Well, there's a couple of ways we can rewrite this. Number one, we can actually take the power here and write it outside of the root. So we can rewrite this as the nth root of the x, this time raised to the nth power. Okay, so notice the power just went from the outside, or excuse me, from the inside to the outside. Okay, and that is allowed. You can check that if you do something like, if you put a number in there, if you do like 2 to the third and you take the fourth root of that, that's the same as taking the fourth root of 2 and then raising that answer to the third power. Okay. But another thing we can do is write this as x raised to a power that's a ratio of those two numbers. So let's look what that would look like. So here, because we had x to the m and we were taking the nth root of that, we can rewrite that as x to the m over n. Okay, so the m, the exponent, goes to the top, and then the n that's in the root goes to the bottom there. So we have x to the m over n. Okay? So let's look at how this would work with some actual examples. Let me write some out here. Let's say we had something like the cubed root of x. If we had the fifth root of x squared, or something like 1 over the cubed root of x squared. Okay, so we're going to rewrite all of these using this rule that we have up here. Now we start with the cubed root of x. Okay, first of all, we see that there's a 3 in the root, but there's no exponent written on the x. Now, do you guys recall what that means about what the power is here? That's right, it means it's x to the first. Okay. So what we're looking at here is the cubed root of x to the first. So as I said before, what you can do now is take that exponent and the number in the root and put them into a ratio. So we can rewrite that as x to the 1/3 power. Okay, so again, the power became the numerator of the fraction, or the top of the fraction. The root became the denominator of the bottom. Okay? Everyone all right with that? Cool. Let's try another example. So here, we have the fifth root of x squared. So we're going to write this as x raised to a power. And again, the numerator of our power will come from the inside, the exponent here. And then the denominator will come from the root, the 5. So this becomes x to the 2/5 power. Okay, again, the exponent became the numerator. The thing in the root became the denominator. So it's x to the 2/5. Cool? All right, let's try another one. So here now, I have 1 over the cubed root of x squared. Okay? So what we're going to do here is, first of all, start with the denominator and write that with a rational exponent. So I'd rewrite this as 1 over, and again, and inside I have 2 is my exponent, 3 is what's in my root, so the 2 is going to go on top, and the 3 goes in the denominator. So we have 1 over x to the 2/3. Now we can take this a step further with this one. because we have the x down here in the denominator, if you remember from earlier in the quarter, when you have something in the denominator with an exponent, you can move it up to the top. Become just an x. So not in the denominator anymore. And then the power, down here it's positive 2/3. So when it moves up, it becomes negative. So 1 over the cubed root of x squared becomes x to the negative 2/3. Okay? Hopefully you can read that okay. Questions on that? Fantastic. All right, let's do the opposite now. Let's go from something written with a rational power to a root, because these equalities go both ways. So we can go from left to right, take the roots and write them as things raised to a power. We're going to take things raised to a power and write them as roots. Okay, so let's look at an example of a couple of examples. So if I have x to the 3/2 power. Okay, so remember when we were going the other way, the exponent was what went on the top, and then what was in the root went on the bottom, right? So we want to write this in the reverse. This can become, write my root here. I have a 2 in the bottom, which means that's what goes in the root. And I have a 3 on the top, so that's what's going to become my exponent. I have the second root of x cubed. Okay. But we know that a second root just means a square root, right? Because a cubed root means what multiplies by itself 3 times. Fourth root means what multiplies by itself 4 times. So a second root is what multiplies by itself twice. And we know another name for that is just a square root. So this becomes square root of x cubed. Okay? Questions on that? Great. Also, just to use the other form we have here, we can take this, the square root of x cubed, and rewrite it so the exponent is on the outside. So I could take this and write this as the square root of x, and then take that whole thing and raise it to the 3rd power. Okay, so again, I just took the power that was on the inside, or right here is on the inside, and moved it to the outside. Okay? Now let's look at one more example of this. Let's say we have x to the negative 1/4. Okay? Now before we deal with the exponent there, we need to pay attention to the fact that it's negative. So because it's negative, if you remember from that example we just did a couple minutes ago, that means that this whole term here can get moved down to a denominator. So we can rewrite x to the negative 1/4 as 1 over x to the 1/4. Okay, like this. So notice, again, we went from negative exponent here to we moved it down to the denominator and the exponent became positive. Okay. Now what we want to do is take that and write that in a root form. So we're going to write this as 1 over. Now again, the numerator here is 1, the denominator is 4, so that 1 becomes our exponent and that 4 becomes our root. So I have 1 over the 4th root of x to the 1st. But we know x to the 1st is just the same as x, so this becomes 1 over the 4th root of x. Okay? And that is where we'll leave that one. Any questions on that? Great. Okay, let's look at some other versions of problems like these. Okay. So, let's say we had something like this. The 6th root of x to the 4th power. Okay? So I'll do a little algebra here, or a little more algebra, I should say. So based on what we were just talking about, we know we can write this as x to a power. And in that power, the numerator will be a 4. denominator will be a 6. So we have x to the 4/6. Now, when we look at the fraction we have there, can that fraction be reduced? Yes, you guys are right, it can, right? Because both of these numbers here are divisible by 2. So we can reduce the fraction by dividing them both by 2, which will become x to the 2/3. Okay, and that's where we'll leave that one. So really, it's the same as what we were just doing, just adding some an extra step there where we reduce. Okay, let's look at another example like this. So let's say we had the 12th root of t, and then that whole thing raised to the 6th power. So something like this now. Okay, so it's the 12th root we're taking, but the 6 is on the outside. Well, again, like we said, even though the exponent's on the outside, this still works the same as the last one. So I can write this as t to the power of 6, because that's our exponent, over 12. That's our root. And we're taking the 12th root. And then t to the 6/12 can again be reduced, because both of those numbers are divisible by 6. So we can reduce this to t to the 1/2. Okay, and that's what we get there. Any questions on that? You guys are so good. All right. A few more things related to this. So before we do this next step, we need to recall some of our rules about exponents. So if you guys remember, we were working with these last week. We were doing some stuff with roots. So we have something raised to a power times the same thing raised to another power. So in this case, x to the a times x to the b. Remember that to multiply those two, we need to add the exponents. So x to the a plus b, there. Okay. We have two things being divided that are raised to powers. Okay, x to the a over x to the b. Then we now need to subtract those. This become x to the a minus b. Okay. Then we also remember that we have a power of a power. And be careful here, this kind of looks like what we were doing just a second ago with the roots and the powers, but it's a power and a power. So x to the a raised to the bth power. Remember that we multiply the exponents in that case. So here we'll have x to the a times b. And then finally, we just looked at a couple of these. If we have something raised to a negative exponent, so if something like x to the negative n, what that then becomes is 1 over x to the n. So we move it down to the denominator and make the exponent positive. You guys remember all those? Sweet. Okay, so let's look at how we can use these together with our rational exponents. Let's say we have a problem like this. The cubed root of x times the square root of x. And we need to multiply these two things. Now, based on what we did last week, we right now cannot multiply the two x's, because even though they're both under roots, they're under different roots. So here we have a cubed root of x, although here we have a square root of x. Okay? So in order to be able to multiply these things, we need to use rational exponents. And here's how that'll look. So cubed root of x, we know that's an x to the first under the root, even though there's no exponent. And it's a third root, so this can be written as x to the 1/3 times, here we have the square root of x, which again, we know the x has a power of 1. This is just a square root, so we know we can think of that as being a 2 there. Okay. So this square root of x then can be written as x to the 1/2. All right, so we have x to the 1/3 times x to the 1/2, which, as we just talked about up here, because they're being multiplied, they have the same base. We can add the exponents. So we can do 1/2 plus 1/3. Okay. And here, we're adding with fractions. So we need to get a common denominator. Between 2 and 3, that common denominator would be, 6. Okay. What we're left with here is x to the, we change the 1/2 of the denominator to a 6, the top will become a 3. Plus here on the 1/3, if we change the denominator to 6, the top becomes a 2. So we have x to the 3/6 plus x to the 2/6. Remember, when you add fractions, you just add the numerator, so we'll have x to the 5/6 power. Okay. And then we can finish this by rewriting that back in radical form. So we see that we have our 5 on the top, so that'll be our exponent. Our 6 on the denominator, so that'll be our root. This will become the 6th root of x to the 5th. Okay, 6th root of x to the 5th. Is everyone okay with that? Great. All right, let's look at one more of these. So let's say we had something like this, the 4th root of q. Divided by the square root of q. All right, so again, as we learned last week, you might think that we can put both of these under the root, but we can't because they're different roots. Okay. So what we're going to do first is rewrite each of them with an exponent. So on the top, we have the 4th root of q, and this is like q to the 1st with the 4th root, so this becomes q to the 1/4. Over here on the bottom, we have square root of q, and this is very similar to the square root of x that we're just dealing with. So it's like q to the 1st. The root here would be like a 2, so this would become q to the 1/2. These are being divided, so it's q to the 1/4 divided by q to the 1/2. So based on what we have up here, that means we need to subtract the exponents. Okay? Q to the 1/4 minus 1/2. Okay, so the top exponent minus the bottom one. We again need to get a common denominator here with the fractions in order to be able to combine them. So we have a 4 and a 2, so the common denominator should be 4. Q to the 1/4 minus, we change the denominator on the second one, so the 2 becomes a 4, so we multiply that by 2 to get that, so we multiply the top by 4, or excuse me, by 2, so we get 2/4, so 1/4 minus 2/4 is q to the negative 1/4, which then we can continue using our exponent rules here. This is negative, so we can put it down in the denominator. 1 over q to the 1/4, and then rewrite that in radical form. So it's q to the 1/4, so the 1 becomes the exponent, the 4 becomes the root. End up with 1 over 4th root of q. Okay, that'll be like q to the 1st there. Any questions on that one? Great. Okay, one more. And now that we have these nifty exponent rules, let's use them to solve some stuff. Let's suppose I had something like this. 6 times x to the negative 1/2 equals 18. Okay? Now this looks a little crazy, but we can handle this. All right? So just like we've been doing with all of our solving equations this quarter, the first thing we want to do is isolate our term with the variable. So here I see I have an x to the negative 1/2 times a 6. Okay, so we need to get rid of the 6. And because the 6 has been being multiplied, that means we do what? Y'all are right. We divide by 6. Okay. Divide by 6 here. Divide by 6 here. We end up with x to the negative 1/2 equals 3. Okay. Then the x to the negative 1/2, we'll do a little work with that now. So we know that the negative sign there means we need to flip it over. become 1 over square root of x. Whoops, sorry, I skipped a step there. Be 1 over x to the 1/2. Okay. And then we know that that 1/2, the 1 becomes the exponent, the 2 becomes the root. So this is like a second ago, 1 over root of x. Okay. And now notice, even though we have a square root of x, it's down in the denominator, which, as we discussed before, we can't have that, or we don't like that. So when you get it out of the denominator, so the denominator means it's being divided in it, so to get it out, we have to do the opposite, which is multiply. Multiply by square root of x on the left and on the right. Here the root x's will cancel. 1 equals 3 square root of x. Okay. And then over here on the right now, our root x term is with that 3, so we got to get rid of the 3, which means we divide by 3. Okay. So we end up with 1/3 equals square root of x. And then we have to undo the square root at this point, which we learned last week. You do by squaring, right? Square both sides. Okay, on the right-hand side, the square and the square root cancel out. If x equals 1/3 squared, which means 1/3 times 1/3, which you can write out square the top and the bottom and the top, excuse me. Either way, you get x equals 1/9. Okay? Questions on that? Alright guys, thanks for watching the video. Hopefully now you can do the handout and bring that with you to class on Wednesday. And I'll answer any questions and you will submit it for credit. Alright, thank you guys.